Okay, so we've already marked up the side of the reference material that has the periodic table on it. So I want you to go ahead and flip it over and begin in this section that shows your formulas. I want you to begin by drawing your formula triangles so that they can help you out if you need to manipulate those formulas for some of the physics problems on your exam. I then want you to move down into the bottom section of this side of the reference material where it's blank, and I want you to divide it into the section shown. You're going to use a little bit more than half of that section to draw your moon phases, and then the rest is going to be used for crustal features and a little bit of biology vocabulary. Once you've completed that, I highly recommend you draw those two dotted lines that are shown and the sun and the earth. Those dotted lines might help you figure out your spacing for the 8 circles that you need to draw the moon phases. We're going to begin with the circle that is closest to the sun, and that is our new moon near the sun, and it should be completely shaded in. Then we're going to move on to our waxing crescent. Remember, dark to light is waxing. Then we're going to move into our first quarter and our waxing gibbous. Remember that if it's waxing, light is on the right. So if light is on the right, it is a waxing. Then the furthest from the sun is our full moon. Then we begin to wane. Wax on, wane off. So going from light to dark is waning. When the moon is waning, light is going to be on the left. So we go from the full moon to our waning gibbous, to our third quarter, to our waning crescent. We know that it takes 3 to 4 days to move between these phases. And if you want to move 2 phases, it takes about 1 week. We don't know exactly if it's going to be 3 or 4 days for each phase, so we like to say 1 week to move 2 phases. Next, we're going to move on to tides. Remember, at your first and third quarter, we have our neap tide. Our neap tide is our in-between tide. That means when we have high tide, it's not very high, and we have low tide, it is not very low. The neap tide occurs when the sun, the earth, and the moon make a 90-degree angle. So that happens during your first quarter and your third quarter. The other type of tide we have twice a month is the spring tide. The spring tide is your strong tide. It has the highest highs and the lowest lows, and it occurs when the sun, the moon, and the earth are in a straight line. So this happens during the new moon and the full moon. Okay, moving down into that bottom left corner, we're going to start looking at our plate boundaries. We're going to start with a convergent boundary between 2 continental plates. So that CC you see in the corner, that's meant to represent continental plate meeting with a continental plate. When this happens, you get mountains. Sometimes they like to call them folded mountains. So you could write that instead. But when you have 2 convergent plates, you get mountains. When you have a convergent plate between a continental plate and an oceanic plate, or an oceanic plate and an oceanic plate, one gets pushed beneath the other, and we call this subduction. Subduction is still a type of convergent boundary. When you have a convergent boundary between continental crust and oceanic crust, you form a trench and a volcano, or sometimes they call them volcanic mountains. When 2 oceanic plates come together at a convergent boundary, you get an island arc and a trench as your crustal features that are formed. Sometimes they like to call island arcs volcanic islands. That's just another name for it, so you might need to know that. Let's move on to that next section. Divergent. Divergent boundaries are when 2 plates are pulling apart. So when you have 2 continental plates pulling apart, it forms a rift valley. And when you have 2 oceanic plates pulling apart, you have a mid-ocean ridge. A really popular example of a mid-ocean ridge is the Mid-Atlantic Ridge. It's right in the middle of the Atlantic Ocean. The next type of boundary you have is a transform boundary. This is when plates are sliding against each other in opposite directions. And this is where you have fault lines form. Fault lines are just giant cracks in the Earth's crust, like the San Andreas Fault. Along these fault lines, this is where we have our massive earthquakes, like the ones you see in California or you hear about in California. Okay, in this last section, this bottom right-hand section, we're going to just go over a little bit of biology vocabulary. I want you to write down biotic. Remember, bio, B-I-O, means life. So biotic factors are those that are living. Abiotic are non-living. Autotroph makes its own food. It's any organism that makes its own food. These are your producers. And you can remember that because auto means it does it itself. So it makes its own food. Heterotroph have to consume food to get their energy. So these are your consumers. Prokaryotes are organisms that have no nucleus. You can remember pro, no. And eukaryotes are like you. These are all your organisms that do have a nucleus in their cells. So you have a nucleus in all of your cells. Thank you. Get this done by the end of the class period. And I hope it helps.